Hi everyone, today we're going to be finding the equation of this straight line. So this could be useful, one, if you're given a situation like this where you're presented with a graph, or secondly, if you're given a scatter plot and there's a line of best fit on the axis and you're asked to find the equation of that line. This is the process that you might consider doing. So, first step, I'm just going to write out our generic version of a linear equation. So that's y equals mx plus c. Just fix my x there. If I can find the value of m, which is our gradient, and if I can find the value of c, then I will have successfully found the equation of this line. So first step, we're going to find m. I'm just going to title this Find M. M is our gradient. So hopefully we remember that the gradient is the rise over run. And we could also write this, we could also write the rise as y2 minus y1 divided by x2 minus x1. So we need some coordinates from this line. I'm going to choose two coordinates. They've got to be on the line itself. And I'm going to choose two coordinates that are nice and easy for me to read. So first one I'm going to choose is this one in blue just here. That would be x1 and y1. And if I look down at my x value for this coordinate, that occurs when x is 4. If I look across to my y, that occurs also when y is 4. So this coordinate is going to be 4, 4 in brackets. Next, I'm going to choose another coordinate on that line. So I'm going to go down here and choose this one. Again, we can title this one x2 and y2. And if I go down to my x value, that occurs when x is 8. If I go across to my y value, that occurs when y is 2. So this coordinate is going to be 8, 2. Okay, now we can start to substitute some values in. So I'm looking for my y2 value. I'll draw an arrow just for the first one, but my y2 value is just this one here. So y2 is equal to 2 minus y1, which is 4, divided by x2 is 8 minus x1 is 4. 2 minus 4 is negative 2, divided by 8 minus 4, which is 4. Negative 2 divided by 4 is negative a half. Okay, and remember we're solving for m. So that's interesting. Now I can go back up to here and I can substitute that m in for negative 0.5, which we just found. So I'll just continue it down below. We've now got y equals negative 0.5 x plus c. We're not quite finished yet. That's not quite an equation yet. We still need to find out c. So second step, and I might go over to, well, I'll keep it going down straight. So second step is finding c. If we go back up to the graph, the graph actually doesn't show you where the y-intercept would be. If we had a look graphically, it would actually be up around the point. If I was to continue this line, it's going to be up around this point up here. but guessing is not really the best method, and I would advise against that. We can actually substitute some values in and solve for C so we can get an exact number. So how we do that is we can choose one of these two coordinates, either the 0.44 or the 0.82. I might choose the 0.44 just to keep it nice and simple, and I'm going to substitute that into our equation that we know. So I'm going to substitute sub 44 into I, and I'm just going to title I as this equation just here. So these two things are the exact same thing, just so I don't have to write out the whole thing again. So instead of my Y value, I'm going to put 4. That's coming from my coordinate. So 4 equals negative 0.5 times my X value, which is also 4, plus my C value. Okay. The brackets there just means time. So I'm going to keep this 4 where it is. We've got negative 0.5 times 4. So that equals negative 2. And plus C over here. We want to try and get C by itself. So if I have negative 2 on this side, to bring it to the left-hand side, we need to add 2. So 4 plus 2 is 6. Negative 2 plus 2 is 0, so we're just left with C. So C equals 6. That is interesting. Now if I substitute my C value into our linear equation, I should have the whole thing. Y equals negative 0.5 X plus our C value, which we've just worked out, is 6. So there we go. We've just found the equation of a linear equation using a few substitution methods. Hope that was helpful.